Software factories. This is a new term in 2026. This is basically everybody now saying that you should be able to build out anything and everything if you just have a software factory. Software factory basically means having a factory that is going to build the software for you. I think the way people are taking a look at it is very wrong, in a sense that we now remember that when we initially installed OpenClaw, we thought that software industry is going to change and OpenClaw is now going to, let's say, build out the software for you. And what companies are going to do is they are just going to hire the OpenClaw as agent, give it different, let's say, the employee name, and it is going to do the work for you just like any other employee. But this has not happened yet. What has happened is so far is that people were able to develop, let's say, the agents kind of infrastructure. For example, OpenClaw, maybe a Hermes agent. Well, I think OpenClaw is a very good example. People were able to build the OpenClaw itself, but people are not really able to, let's say, use the OpenClaw to build something meaningful. Let me explain it to you in this video how this guy Chamath, he's actually taking this problem in a very different way, how he has raised $100 million so far, and how this guy is probably going to make another $100 billion company out of Silicon Valley based on vibe coding, based on software factories. This is going to be the future of software services. So to start with, why I think OpenClaw was actually just a mirage. What you can think of it is like there is a teacher model and then there is a children model, right? So the teacher model is basically the bigger model, the model that is going to let's say have a very large amount of weights, like for example maybe 1 trillion weights, right? And then this is a model that has been trained, for example Opus 4.8, right? This is a very big model, and then Haiku comes out as a very small model, right? If let's say you are able to run out a lot of queries on Opus 4.8, or if you are able to run a lot of queries on Fable 5, you will be able to actually replicate and build Haiku on its own. And this process is known as distillation process. This distillation process, there are a lot of, let's say, research papers about it too, by DeepMind. And what basically it means is that you should be able to, let's say, build out a smaller model out of a larger model by actually asking it or giving it a lot of prompts, input and output, and then actually training the data based on that in a simple form. Or there is also the other way, which says that you can prompt the smaller model also 10 times just to collect, let's say, 10 times more data, because smaller model is going to use less tokens, it is going to output less tokens. But if you just prompt it 10 more times, you will be able to, let's say, build or replicate something similar to the same model as well. But it is not going to be better, it is going to be, let's say, a little bit lower than that. You can say 10% low, right? And that is how China have been, let's say, maybe using Opus 4.8 or some of the other Anthropic models to build the models of their own. Not the acquisition, but I think of course China have done a lot of innovations as well, but this is a way, this is a process that you can do. So what has happened is that Cloud Code was initially trained as the teacher model, right? Cloud Code basically also was a student of something, like let's say there was a Fable 5, right? Fable 5 was, let's say, their internal infrastructure, whatever they currently work on, and Fable 5 is, let's say, the default development environment in Anthropic, you can say. Now Fable 5 is the teacher model. Fable 5 is whatever they will use for the development purposes, right? And what's going to come out of it is a Cloud Code. Cloud Code is basically the harness layer built around models. So if you want to understand it, basically these models such as Fable 5, Opus 4.8, they themselves are not able to, let's say, use your repositories to do a lot of code, because they don't understand the context that well, right? They don't understand 1 million context, they don't understand even, let's say, the 10,000 lines of context. It will be very hard for you to actually upload all of the repositories on, let's say, Cloud Code, and then ask it to tell you that what code or what lines of changes you need to do, and then expect it to actually return you the output of the repository or a PR that is going to make that change for you. unless the change is very small. It is just in the readme file. So what happens is that cloud code is basically a layer that is built on the top of these APIs that are these models, right? Fable 5, Opus 4.8, and this harness layer, this cloud code, this is a tool that sits on your system which crawls all of the code that you have, which, let's say, makes the memories as you talk to it, and then which compacts the memory as you talk to it, which remembers what you are trying to do, which remembers your goal, which also is, let's say, able to use some of the prompts that maybe are pre-written by cloud code, for example for designing purposes, for example for architecture purposes, and for example for AI agent purposes. And this is where I'm coming to. Cloud code itself was built as a platform for you to run agents. Cloud code itself was built as a platform for you to use those agents to do the development, right? Now what happens is, let's say if you use cloud code to build OpenClaw, you already have a teacher model. You already have the prompts in the system that understands how to build the AI agent, that understands how to do the coding development, right? Because this is what was initially used by Anthropic to make cloud code. So cloud code is itself trained on this data that is already there, and cloud code itself has a lot of prompts that understands how to use AI agents. That's why you are able to, let's say, do a lot of development just by doing the simple prompts, by not even managing the systems or structure. And Fable 5 or these models don't really even work that well if you just use some basic templated prompts. They work very well if you give them very specific instructions, right? So now when OpenClaw comes in, OpenClaw is basically a student model of cloud code. That is what I'm trying to argue. OpenClaw is not a new invention. It was not that Peter, the guy who founded the OpenClaw, was sitting somewhere and then he was like, okay, this problem is not solved yet, right? This is a new problem. Nobody is able to, let's say, do the messaging to their friends when they are sitting in a different country. So let me try to develop this new protocol. That is not what has happened, right? What has happened is that he has built the UI layer for cloud code. Initially, cloud code was basically, you was only able to use it through terminal, but you didn't had access of it through Telegram. Now, when the OpenClaw comes in, OpenClaw basically gives you the access to Telegram through your cloud code, right? And then it is able to build out the UI layer, which is all about agents only, and it has no design aesthetics, by the way. That is true. It has no design aesthetics, and the kind of errors that it has is just massive. That is why it is a student model, because its parent teacher also has the bugs. Cloud code itself has a lot of bugs. Cloud code took a lot of time to just solve the flicker problem, right? So cloud code is basically the teacher model, and then OpenClaw comes in as a bad student, right? You can say. Now what people initially thought is that, okay, now they will be able to, let's say, install or hook the OpenClaw in their system and it is going to solve the problem. But what they didn't understood is OpenClaw is basically a cron job or API layer or agent, or you can say a personal agent for you that only wakes up when you message it, or that only wakes up when there is a cron job going on, right? And then it is able to do the task for you, but it is mimicking that it is behaving as a person. It is not a person. When the person goes and then, let's say, take a leave for 2 days, he comes back with ideas because he's consciously thinking about the problems, the same problems that he has been trying to solve, and he solves them more creatively. This doesn't happen with OpenClaw. If you stop OpenClaw for 2 days, it is going to just come up with the same bad problems that it's trying to solve. And there is a bigger problem to this system as well. The bigger problem of this system is that cloud code itself was trained on the software engineers, let's say, a lot of commits, you can say. It is not trained on how software engineers think. It is not trained on how businesses think, because businesses and software engineers just use internet to only commit whatever is already done to share with other peers. They never shared how they did it. They never shared how they thought about it. Now, when there is a model that is just trained on the output of what the human mind thinks, it is not going to, let's say, understand how human mind thought about it. So it has to make stuff up. It has to make shit up literally on the real time, right? Now, the thing that I think what Japa, basically the director of OpenAI, not the director of OpenAI, but there is this company called Japa, the models that the director of Meta is trying to solve. He's not at Meta anymore, but he's trying to solve this problem by actually saying that you shouldn't be able to, let's say, just use these large language models to solve the world problems, because you don't understand how minds think, you don't understand how humans think, right? So this is a basic fundamental problem that I'm talking about. But this guy Chamath, he was able to solve it, he was able to crack it, and now I think he's going to have $1 billion company or $100 billion company in reality, which is not going to be the another OpenClaw slop kind of app, which is going to be the real company, right? Now, if you talk about it, OpenClaw, this guy Chamath, he's building the 8090 solutions, and this 8090 solution is basically the company that is going to do the software development for businesses. So basically, if you look at their motto, right, enable every enterprise to benefit from purpose-built, transformative, high quality software. Now the biggest worry of the enterprises is that yes, they will be able to, let's say, give out the responsibility of refactoring to Cloud Code or to Codex, right? But there is no ownership in there, right? So what he has understood is that yes, the agents are able to do a lot of development for you, but only if you have given it some guidance, only if people who really understand the architecture are able to teach it that if you have to scale the messaging model, you have to understand the distributed systems, and if you have to, let's say, scale the database, then how do you actually scale the databases, right? How do you use the Vercel properly? How do you use the infrastructure properly? How do you use the AWS properly? What are the safe policies to implement, and how to basically build the security layer, or how to build the auth layer? So there are people who are capable of understanding these things because we have been doing it for, let's say, a long time. So but this guy comes in and says is that okay, what you're going to do is you're going to deploy the AI agents. By the way, I think this is literally $1 billion idea. This guy is going to deploy the AI agents for you. He's going to, let's say, you are not going to directly use Cloud Code, you are not going to directly use Codex, you will be able to use it through the software factory. And when you use it through the software factory, the cost of the using model initially comes down by half. Basically, if you pay $1 through this company, you only have to pay 50 cents, because he has built the harness layer around it, he has built the specs layer around it, he understands how the software builds. He was the director at Meta when Meta wasn't a thing in 2011, in 2008, in 2009. He was the senior director in advertising industry, and then he was also he has been the venture capitalist since 2011 in Silicon Valley now, right? Now when this guy comes in and says that okay, like, we're going to build a software factory, you have to listen. Now the one thing that really matters in this is that you own the business logic and workflow. So if you as a company or enterprise does a contract with 8090, he says that you will own the business logic and workflows, which is very important for any business, right? Like if you're in the insurance industry, it is very important for you to tell software what the business is you do, right? It just can't vibe code up the policies, and 8090 is going to own the code base, IP, and delivery responsibility. Now this is, I think, where the magic comes in. But I think he's going to do is, I think he has already done it, he's going to go to big companies and look at the problems that they are not able to scale. But this is the fundamental of startups. Listen, do things that don't scale, and founders work very hard to scale that, right? Now what are the things that don't scale? In the today's industry, there are very less people who understand COBOL. There are very less people who understand assembly language. There are very less people who maybe understand C as well now, because these are old languages. These are old infrastructure, and people don't even look at the code anymore, right? Now, when this guy comes in, he says that okay, what you are going to do is you're going to take a responsibility of all the assembly code that you have, all of the bad code that you have that has been written in the languages like COBOL, where you're not able to hire the engineers. We are going to look at your millions of lines of code, and we're going to do the refactoring for you, where you are able to use these millions of lines of code. And the way we will do that is by doing the refactoring. We will be the one who will be doing the code refactoring, but the way we will do that is by giving you the platform where you will be able to, let's say, add the business logic and workflow into it. So this is his whole idea. The whole idea is that this software factory is going to, this is, by the way, very important. There are like 5 rules to what he has built, right? So the first rule is that you should be able to define the requirements in the So this interface is also, like, you can say the product managers can themselves use it, the product guy can use it. He don't need to understand the architecture, he don't need to understand the software. He will be able to, let's say, write down the overall requirements. And let's say you are the insurance company who have 18 million lines of code of running the insurance corporation. You will be able to write down the requirements for that. The second thing is, it will develop the blueprint for you, which you can then take it back to, let's say, whoever the software architecture is in your company, and then get the approval for that, or maybe give the feedback for that. Then you will be able to develop the task. The work orders are basically AI agents who are themselves going to do the task for you. You have to be the reviewer of that. And then for example, there is a 17 million lines of code, and one of the first story is going to be that, okay, we are going to define all of the policies and rules that you have. Now these policies and rules, it will explore and then look at the code base and then try to, let's say, show it to human, and then human can give it a feedback that, hey, I think there are these 100 different rules that are part of this rule, so you should explore and find out that as well. And then till the human is able to understand, or the human is able to, let's say, teach everything to AI agents by literally talking, just like humans do. Well, that is how I think this software is going to do the refactoring for you. And then it is going to do the tests for you. The tests are basically going to be that, are these policies implemented or not, let's say, and then there will be a feedback loop as well. Now what's going to happen is, when he will do it for first time, and there are stories as well of the same thing, by the way. So when he's going to do this thing for the first time, it is going to be, let's say, harder for you, because you yourself need the people who understand COBOL. You yourself need people who understand how the insurance company works, maybe, and how to build the harness layer around it. Harness layer in the sense that how to actually solve this problem. And AI agents themselves are going to solve this problem for the first time, but it will build the memory along the way. It will build the memory that how it was able to take the business idea and then convert that, how it was able to take the requirements, how it was able to take the blueprint, what feedback it got from the architecture, what kind of a work orders it was able to deliver, what kind of a test it wrote down which didn't work out well, and it received the feedback from the human or from the another AI agent, and then it is going to do the job better next time. And it is going to become specialized in just refactoring the COBOL code, let's say. And who owns the COBOL code? A lot of companies. So as per the case study, not here, but he worked with one of the companies where they had 18 million lines of code, insurance company, and just because he refactored it for them, now they are able to sell the insurance at the lower cost, because it was literally written in COBOL language, which they were not able to refactor, thus they were not able to change the prices, but they were able to take the prices down to a lot more. And the another layer is going to be, he will understand how to use open source models. So tomorrow if Fable 5 goes down, you don't need to worry about it, because his software will be able to also work with the other models, such as open source models like DeepSeek, right? Now, coming back to it, how this model is different from OpenClaw, because OpenClaw itself assumes that you will be able to do everything just by telling the engineer or by telling the OpenClaw to do everything for you. It doesn't look for the feedback, it doesn't ask for the feedback, or it doesn't really learn from you, right, in a sense. But Chamath has built is, he is going to deploy the OpenClaw, like let's say 100 OpenClaw in his software factory, where it is designed to be built around business, how the business works, right, how the specs works, how the requirement works. And then he's going to collect a lot of data, and then he will be able to collect a lot of data in several dimensions. Let's say the companies who just work in building the distributed systems, which are very large in nature, and they have to send a lot of messages. Well, he just solved it for one company, he scaled it well, and then now he's able to solve the same problem for other companies as well. And now what happens is, there are companies like Infosys who have 100,000 employees right now. He will be able to solve the same problem with just 100 employees, because those 100 employees just need to solve the same problem for one company at let's say from going from 0 to 100 million users. And now any company that comes in who need 100 million users, the AI agents themselves understand how the software engineers have built the software. They have the thinking process, they have the thought process of how software thought of coming up with these ideas, because those software engineers are themselves the AI agents who will be trained to write down all of the memories and the logs, and then tomorrow he can also come up with a new harness layer, not the model itself, which will be specialized in, let's say, cybersecurity or messaging system or the design layer or refactoring COBOL or refactoring assembly or building out the good hardware processes or building out the good drone applications, right? So there are going to be several of these verticals that are going to show up, which are going to be specialized in let's say the specific domain. OpenAI is already coming up with a soul model, which is very good at cybersecurity. Same way Chamath is going to come up with 100 different verticals, and these 100 different verticals, one of the company is going to come to them, who they are going to solve the problem for that one company, learn about it, and then figure out that how the AI agents can do that autonomously in future. So you have to solve that problem first, and then the way they do that is by just doing it in a hard way, and now it can be literally automated. So that is, I think, the future. The software factory is the future, but you have to understand that OpenClaw is not the future. The software factory is the future. The software factory where it is able to collect the human thoughts is the future. Japa is maybe takes a bit of a time because it has to come up with a new architecture, but software architecture, software factory doesn't have to. So if you are designing the software factory, design it around this process, that how can you work with 10 different agents, let them develop the application for you, and then the way they develop the application is not by you coding but them coding, but along the way you have the business team and you have the product team and you have the engineering team, or you maybe also have the design team, giving them the requirements, asking them about the feedback, telling them that how do you scale from 0 to 100 million, telling them about that, okay, there is a world outside Versal as well that you can deploy in AWS. There are all these different services where actually agents are able to collect the memory, and they are able to, let's say, you are able to, let's say, build the parent model where you are able to scale something from 0 to 100. Now you should be able to scale something from 0 to 80. So building out this parent model is very important, and then you can't just expect Cloud Code to be your parent model. You yourself have to be the parent model. Your company yourself have to be the parent model, and then your own idea has to be your parent model. That is why only how you will be able to automate the children models and then make a money. And I think Cloud Code is literally making money by just being the parent model and then letting all of us be the children model. So someday you have to be the parent as well. So why don't you start being a parent from today onwards, and then build out a software factory. Thank you. This is my whole thesis for today. We are going to build out the software factory as open source project as well. So do subscribe me, and we will launch a new course called Harness Engineering, which is going to be about this specific topic of how to build out these parent models and how do you actually, let's say, build out something useful which will be able to either get us employed or solve the problem in a company that we are trying to solve. All right. Thank you.